Now we're going to solve a system of equations where one of the equations is a quadratic and one is a line. So basically, we're going to see where this parabola and this line intersect. We are going to use the substitution method. And we can see here, we're going to take the bottom method, solve it for y, and plug it into the top method, because we don't want to plug into the top method for x, because then we would have to square our values. So we take the bottom equation and we solve it for y by adding 3x to both sides and adding 3 to both sides. Now we can plug that into the top equation. We're going to distribute the negative, combine like terms, and now we have a quadratic. So using the substitution method, I started with 2 equations and 2 unknowns. And now I have a much simpler 1 equation and 1 unknown. So to solve this quadratic, we're going to use the factor by GCF method. So we're going to factor out the greatest common factor, which is the 3x. Now that it's in factored form, I'm going to factor, split, and solve. So I split this into 2 equations, 3x equals 0 and x minus 1 equals 0. Solve those equations and I get x equals 0 and 1. But I'm not done. I have 2 variables. I have an x and I have a y. So I'm going to take the 0 and I'm going to plug it into y equals 3x plus 3. I could have chosen any of those equations up there, but this is the easiest one to find the value of y. So when I plug in x equals 0, I got y equals 3. So that's one ordered pair. Now I'm going to take x equals 1 and plug that in to the same equation. When I plug in x equals 1, I get y equals 6. So 0, 3, and 1, 6 are where the parabola and the line intersect.